Welcome back. Today we're going to go through quadratic equations with real solutions and complex potential solutions, but we're not going to get into complex numbers so much today. A quadratic in general looks like this. There's always an x squared or a t squared or something like that as we're looking at it. And we have many ways of solving them. This first part is relatively simple. This is the most basic. If we take number one here, 10x squared plus x, and I'm going to subtract the 2 over, so minus 2 equals 0. And we're going to factor this one. However you learn to factor, your past teachers taught you how to factor. 2x plus 1 equals 0. This is referred to as the zero product rule. This is what I'm about to do here. When I have two things that are being multiplied and they equal 0, one or the other has to be 0, possibly both. And you can see I can add 2, divide by 5, subtract a 1, divide by 2. And in this case, we have 2 answers. The problem is most quadratics don't factor evenly. So we're going to run into some other methods on how to do that. Now, this is what we call 1a. Let's do 2a. The second way is extracting square roots. So if I have x squared equals 9, what I can do is I can take the square root of both sides, but I got to keep in mind when I take the square root of both sides, I need both the positive and the negative answer. So x equals positive and negative square root of 9, or plus or minus 3. And we would write that as x equals 3 comma negative 3. You put the word or in between. Part B here. I'm going to go ahead and add the 5 to both sides, so I get equals 12. And I'm going to do that same rule. Don't forget the plus or minus. And if you remember, when you simplify that root 12, you're going to get plus or minus 2 root 3. And then I'm going to subtract 3 to both sides, giving me x equals negative 3 plus or minus 2 root 3. And if you needed to write those out, and if need be, we could even get a decimal approximation. I'm not going to get a decimal approximation for every one of these that we've run into, but I'm going to show you every once in a while how we do that. So I would go, now make sure you use the negative button, not the subtract button for that negative 3. If you hit the subtract button, you'll most likely get an error. Negative 3 plus 2 square root of 3. 0.464, we'll say. We have the subtract one, negative 3 minus 2 radical 3. And to be clear, that first negative, that's the negative button. The second one is the subtract button. 6.464. So depending on your homework system and your teacher, this may be okay, these may be okay, these may be fine. All right, moving on, part 2. We're going to solve quadratic equations by completing the square. And for this first one, I'm going to add that 5 to the other side. And what I'm going to do is I'm going to take the 6, I'm going to cut it in half, I'm going to square it. So that becomes 3 squared, which means in reality what I'm doing is I'm adding a 9 to both sides of the equation. Nine comes from 6 divided by 2 is 3. 3 squared is 9. Now I've now completed the square. Now what I'm doing is I'm employing this rule, or I'm forcing this idea, and the general rule here is this. And I'm forcing this condition so that I can write it here. This is going to look like this. So this gives me x plus 3 equals plus or minus root 14, which means x equals negative 3 plus or minus root 14. So there's the answer for the first one. The second one gets a little bit intense. So I went ahead and added the 7 to the other side. What I'm going to do here, because that lead coefficient is not a 1, I'm going to have to divide through by the 4. And I'm going to do the same trick I did before. That coefficient there is now a 1. Now, when it's even, it's easy to cut it in half. When it's not even, you got to be careful. So I'm going to take the 1, I'm going to cut it in half, and I'm going to square it. So in reality, I am adding a 1/4 to both sides of the equation. This becomes x plus. Now, the way that I know what this is going to factor into is it's always the square root of that, and it's always half of whatever number is there. So this is going to be literally 1/2. And I already have a common denominator, which is very nice. So I get 8/4, which reduces to 2. And now I can use my rule. And subtracting the 1/2 to the other side, x equals negative 1/2 plus or minus root 2. So there are my two answers. And again, your teacher may want you to break it up into two separate ones or even get a decimal approximation. And I'm going to leave this last one for you to work out. You're going to use a similar strategy to what you did here. All right. Next page. Part 3 is the quadratic formula. So what I did was I typed up for you exactly where it comes from, and it comes from completing the square, the process we just did. Move the c over, divide through by a. Take b over a, cut it in half and square it. So in this case, it becomes b over a times 1/2 squared is the b squared over 4a squared. That's where that comes from. And that. We get a common denominator on this side. This side we factor, remember it's the square root of all that, so b over 2a, or it's half of that, which is b over 2a. Take the square root of both sides, plus or minus, subtract the b over 2a. You'll notice when you take the square root of the denominator there, you also have a 2a, so they end up being the same denominator. And there is our quadratic formula in all of its glory. So, good thing about quadratic formula is that it will work with every quadratic equation. So let's use it on this one. To be clear, a in this case is 6, b in this case is -8, c in this case is 1. So I'm going to plug in there. Be really careful with the minus minus. Also, when there's a subtract there, if a or c are negative, then it'll turn into a plus maybe. So just really keep an eye on your negatives there. So again, we got that double minus going on there. This becomes 8 plus or minus root 40. over 12. Now, of course, we need to simplify that root 40. And I got to continue to do this. I'm going to go ahead and factor out a 2 from up top, 4 plus or minus root 10 over 12. And of course, the 2 and the 12 reduce. To a 6. Traditionally, this is how we write it. Your teacher, if you had to write it as 2 separate, would look like this. Comma. And I'll even get us decimal approximations for this. So 4 plus the square root of 10. I hit enter, and then I hit divide by 6. If you don't, then you could run into some problems. 1.19, we'll say, or minus the square root of 10 equals, then divide by 6. 1, 4, we'll round it off. So again, here's the 3 different ways to present your answer, with the plus or minus, breaking it down into the 2 separate, and then actually getting decimal approximations. All right, let's move on to some applications. Projectile problems. So Sir Isaac Newton came up with this formula. In fact, he was messing with creating calculus when he, this is one of the results of him doing that. So if we're in feet per second squared, the acceleration of gravity is negative 32 feet per second squared. And if we're in meters per second squared, which is the metric, the standard, it's a negative 9.8. It's negative because gravity goes downward. And our velocity for this problem, so the height of the object that has been projected into the air is given by this equation here. There's that negative, it's actually half of that is where that negative 16 comes from. And let's move on to the actual question. A person is standing on a deck 20 feet. Now there's the 20 feet. And above the ground, and throws a ball at 12 feet per second. I'm assuming they're throwing it downward, which means that's going to be a negative 12 feet per second. How long until the ball hits the ground? Now, x is the position. When x equals 0, that means the ball is on the ground. So this literally becomes this, negative 16 t squared, t standing for time, minus 12 feet per second, t. There's the initial velocity, it's there. This person's a positive 20 feet above. They want to know how long until it hits the ground. The height is 0. I'm going to divide this through by negative 4. So this gives me 4t squared plus 3t minus 5 equals 0. I'm going to use the quadratic formula here. And a is 4, b is 3, c is negative 5. So t in this case, not x, equals negative 3 plus or minus the square root of 3 squared minus 4 times negative 5. Now, this is what I was talking about before. I have a minus situation here, so that's going to turn into plus. Over 2 times 4. This is 9 plus, that is 80. All right, let's get some decimal approximations here. Negative 3 plus root 89 divided by 8. I'm getting 0.8042 seconds. And let's try the -1. I don't think the -1's good. If we get a negative time, that doesn't make sense in the context of the question, but let's try it anyway. -3 minus the square root of 89 divided by 8. And you can see we're getting a negative answer. So -1.55 seconds doesn't make sense. So we only have one answer. That is here. All right, we are to more applications. All right. The discriminant is the radicand, that's the part under the radical, b squared minus 4ac in the quadratic formula. If this result is a positive number, then we have two real solutions. If this result is a negative number, then we have two complex solutions or non-real solutions. This part here. If it equals 0, then the equation will have one real solution. If that's 0, then that means we have a perfect square. All right. Let's look at some applications here. A gardener has a rose garden that measures 30 feet by 20 feet. A nice little picture here. He wants to put a uniform border of pine bark around the outside of the garden. So that's the white that goes around it. Find how wide the border should be if he has enough pine bark to cover 336 square feet. First off, I want to point out that the distance is x here and x here, and x here, x here, x here, x here, x here, x here. It's all going to be the same distance because they said they want a uniform border. That makes this length here, from here to here, 20 plus 2x. So x plus 20 is 20 plus 2x. And it makes the distance from here to here 30 plus 2x. So the area of the whole thing is 30 plus 2x times 20 plus 2x. But if I just want the border, I have to subtract out the actual rose garden. So the area of the actual rose garden is the 20 by 30. And that overall area should equal 336 square feet. So this is the area of the entire thing minus the area of the inside. And that just leaves me with the area of the border. And we want that area to equal 336 square feet. All right, let's get to multiplying. So here we go. 30 times 20 is 600. That's going to give 60x. That's going to give 40x. That's going to give 4x squared minus 600 equals 336. And I'm going to notice that 600 minus 600, that works out well. And combining those up, I'm going to get 4x squared plus 100x. And subtract that over. Remember, these are gone. Minus 336 equals 0. Now, we can divide a 4 out of that. Let's bring this up here. So I'm going to divide through by 4. By 4, by 4, by 4. And me x squared plus 25x, let's see, 336 divided by 4, 84, minus 84 equals 0. And this one is factorable. X plus 28, x minus 3. Of course, if you didn't see that it was factorable, you could certainly use the quadratic formula. That's perfectly valid. So x plus 28 equals 0, x minus 3 equals 0, x equals negative 28. In the context, that doesn't make any sense. negative 28 feet versus x equals 3 feet. So that is the side of the border that's going to have the pine bark, 3 feet. Cool stuff. Hopefully we understand why we're not going to use negative 28 feet. Example 4. Suppose that an open box is made from a square sheet of cardboard by cutting a 3-inch square from each corner, as shown, and then folding it along the dotted lines. If the box is to have a volume of 300 cubic inches, find the original dimensions shown. So if I call this length here x, this distance here is x minus 6, right? Because these are 3, 3, and 3. So this inside part here would be x minus 6. It'd be the same for these. So this is the base. This is x minus 6 by x minus 6. So x minus 6 by x minus 6. And the height is 3 inches. X minus 6. The height is 3 inches. So the volume overall is going to be x minus 6 times x minus 6. That's x minus 6 squared times 3. And total volume should be 300 cubic inches. Now I'm going to notice before I do anything, I can divide the 3 out to both sides. So divide by 3, divide by 3. The volume of a rectangular box is length times width times height. That's why it's length times width times height. That's where that comes from. I'm going to go ahead and FOIL that out. We get x squared minus 12x plus 36 equals 100. Moving that 100 over, so 36 minus 100. X minus 64, 0. And, oh, why do that? We just take the square root of both sides. X minus 6 equals plus or minus root 100. So this is coming over here. So x equals 6 plus or minus. We could have done that. It's factorable, but it's already in that form. We may as well 10. So this is going to give us 16 feet, or 6 minus 10 is negative 4 feet, which doesn't make sense. Oh, these are inches. So 16 inches. So negative 4 inches doesn't make sense in the context of what we're doing. So moving on, part 5. Choosing the easiest method to solve a quadratic equation. This is not in stone, and my default is, if you're not sure, use the quadratic formula. It always works if you have it in the right form. So there are 4 methods for solving quadratic equations. Solve by taking the square roots. We've done that already today. Solve by factoring. We've done that as well today. Solve by completing the square. This is the least desirable way to do it. Talk about when maybe it is appropriate to do that. Solve using the quadratic formula. Again, that's my default. So this one we're going to solve by taking the square roots. We can see we already have a perfect square there. So I'm going to add the 5. Divide by 2. Let's go over here. Divide by 2. X plus 3 squared equals 12. And now I'm going to take the square root of both sides. which again is plus or minus 2, 3, which means x equals -3 plus or minus 2 root 3. Not a big deal. Already done that. Example 6, solve by factoring. Now, if they say solve by factoring and it can't be factored, then we have to resort to another method, but we will trust the author here. I'm going to go ahead and add a 14x to both sides. And we're going to go ahead and factor that. Again, however you were taught that factor, that's reliable. That's the method you should be using. And then now we're going to set each piece equal to 0, each factor equal to 0. Subtract the 4, divide by the 5. We subtract the 2. And we have 2 solutions, 2 real solutions. Again, these are all methods that you've learned in the past, nothing new here. This one we're going to solve by completing the square. I'm going to start out by dividing this through by 4. It's always a good trick, if you can, divide out numbers. Right, smaller the numbers, the easier the whole process will be. X squared plus 6x minus 2 equals 0. I'm going to move that 2 to the other side. If you remember, 6, I cut it in half, and I square it. I'm claiming this is now a perfect square. Remember, it is always the square root of that and half of that, 3 in this case. Now I'm going to do the square root to both sides. And subtract the 3. There you have it. All right, we are getting there. And of course, the quadratic formula is the way that always works. I'm going to go ahead and add that 12 to the other side. So we have 3x squared plus 12x plus 7 equals 0. A is 3, B is 12, C is 7. Quadratic formula looks like this. And let's start plugging. X equals 12 plus minus squared 4 times 3 times 7. By 2 times 3. I'm not sure what that is. Let's see. 84, I think. Let's see, 4 times 3 times 7, 84. Now root 60 does simplify to 2 root 15 over 6. I can factor a 2 out of that. And reduce the 2 and the 6. So make sure you do your simplifying as you go through it. And I threw down a few examples here of just when to use what method. So this is the quadratic term, this is the linear term, and this is the constant. If your equation does not have a constant, then factor a greatest common factor out most likely. Like this one here, there's no c, there's no constant term. So just factor a 3x out. Occasionally, instead of being given a problem like this, it'll be given like this. This looks more tricky than it is. All you have to do is subtract the 6x over, and then you're back to here. Factor out the common factor, set them both equal to 0. If your equation does not have a linear term, is the middle term here, the bx. And this should be a subtract. 4x squared minus 9 equals 0. What you can do is you can isolate the squared term and plus or minus take the square root. You might have noticed that this was also a difference of squares. So you could have factored this one into 2x minus 3, 2x plus 3 equals 0, and you'd still end up with the same answer. So both ways could work there. Now, if it's easy to factor, then this is the way that I recommend. If you can see the factors, like just look at it and go, oh, 14 is 7 and 2, which gives me the 9, then factor it. If you have to do a whole lot of work to factor it, I would do the quadratic formula most likely. That's just me. All right. Equals 1, meaning we end up with a is 1 like that. Maybe complete the square, but only do that if that middle term is even. If it's odd, then you get some kind of funky fractions. You can do it, but not totally sure that it's worth it. Even on something like this, I would still consider subtract it over and using the quadratic formula. But if you can see it and it's nice and easy for you to factor into the perfect square like that. Again, they got the 16 from taking that -8, cut it in half and square it. Half of 8 is 4, 4 squared is 16. And then you solve it with the square root. And then this is my spin on it. If all else fails, quadratic formula will always work. So even if you're not sure, you can always follow the quadratic formula like we have been doing. So let's go through and see if we can figure out which of the 4 methods is going to be the best for us. All right, here we go. This one is, we already have it like this. The lead coefficient is a 1, and that's even. So I would say complete the squares. Maybe it's the best way to go with that. So C. When you have the squared by itself like that, nice and isolated, I would use A. I just take the square root of both sides. When there's no constant term, there's no +5 or +9, -6 or something, then just factor out the common factor, which is B. Here we already have something in a perfect square. I would do the square root property probably. That's A. When you have decimals already in it, and even if you get rid of the decimals, you're going to get massive numbers. This one I would definitely use quadratic formula. I wouldn't even bother getting rid of the decimals. I just keep it as it is. That would solve quadratic formula. This next one, I would also, it's not factorable, I don't think, so I would go straight to the quadratic formula. So D for that one as well. Here, I can look and see this one is easily factored. This is x plus 6, x minus 1. So I would factor it. But if it was any more complicated than that, I'd probably go to the quadratic formula. Yeah. With fractions like this, I would multiply through by 15. And then most likely I'd go to the quadratic formula. Don't forget, quadratic formula can always be your default. That will always work. Hope it helped.